we can imagine that ancient people used to think that star stick to a giant celestial sphere. You can imagine, and the sphere is moving, rotating, with the Earth as the center. This is the image of what we can see in the east direction. So you can see that the sky, it seems like a giant sphere. This giant sphere rotating surrounding the Earth. When we see the sky, we just see points from stars. But long time ago, people imagined that the points just like something, like a mythological character. Oh, this is just like a human. Oh, this is just like a crab. This just like balance, and so on. So according to their imagination and their mythology, they try to name formation of the stars as something they know at the time. So this is what see, and next this is what they imagine. And next we can see a line. Did you see the line? Yeah, this line, that is the ecliptic. This ecliptic is the path of solar motion. So we can imagine that the sun move following this line. In 1 year, the sun circle the earth in one circle full. So, but it means 1 year is time for the earth to move revolution surrounding the sun. So this ecliptic passed through 12 constellations in the sky. We know Libra and Scorpio, we know Cancer, we know Capricorn, and so on. In this screen, you can see Libra and Scorpion. Can you see? Near the ecliptic. Yeah. So this is two constellation, which is we call zodiac. There is 12 zodiac we know, but actually there is 13. There is one more zodiac which is not written in the astrology. That is Ophiuchus. Can you see Ophiuchus here? Yeah, near the center. Yeah, that is Ophiuchus. Let's see the movement of planets. Some people imagine that the movement of the planet is similar to a dance. Move forward, move backward, and the speed of the movement is also varying, sometimes slower, sometimes faster. When we see a planet, they move relative to the stars. Yeah, if we imagine that the stars is fixed in the sky, then the planets move surrounding the stars. When the planets move according to the movement of the sun, we call it the prograde motion. But sometimes if it moves backward, so in this motion you can see that the Mars, this is the planet Mars. Planet Mars, first they move prograde, and then they move backward, we call retrograde. How people long time ago imagine of the movement? They believe that the earth is the center of the universe. How they can explain the planetary motion? Sometimes move backward, sometimes move forward. Yeah. So they try to figure out, and they explain that all of the planets move surrounding the earth. The earth is the center, but how they can explain the backward movement of the planets. So they introduced epicycle, a small cycle in which planets also move. Pythagoras believed there is a connection between the sky and the earth. They see the Pythagorean, yeah? Pythagorean is the Pythagoras and their followers and his followers. They see that many sky phenomena has repetition. If there is repetition, there will be a frequency. Yeah. In music, there is repetition. There is also frequency. So Pythagoras believed that there is a connection between the repetition in the sky and the repetition in music. The planets move in the sky with their own periodicity and frequency. They also believe that there are certain proportionality of the frequency in the motion of the planets. So, therefore, such a relation between musical frequency of the planets should exist. Pythagoras have a belief that the Earth is the center of the universe. But Copernicus introduced a different concept of planetary motion. In his opinion, it is possible to explain the planetary motion with the sun at the center. This model is called heliocentric model. Copernicus did not say that the previous theory is wrong. No, he just gave alternative. So this is the model for the Copernicus movement of the planets surrounding the sun. And this concept later supported by the work of Galileo and Kepler. As you know, Galileo is the first person who saw the Jupiter and its satellite. The satellite of Jupiter moves surrounding the Jupiter. So he can imagine that the planets also have a movement similar to the satellites of the Jupiter. Kepler formulated the planetary motion model based on long-term planetary position measurement by his senior, Tycho Brahe. Tycho Brahe has a very accurate, very big and accurate apparatus. It's called quadrant. Using quadrant, he can measure the position of the planets very accurately, much more accurate than previous observation. Kepler realized that the speed of planetary motion in the sky is not constant, and it moves faster and slower periodically. The speed change can be explained simpler if the trajectory of the motion are elliptical. So, in Copernicus model, the trajectory of the planetary motion is circle, but it cannot explain in simple way how the planets can move forward and backward. But using the model of the Kepler, it can explain how the planets can change its speed. Well, this is the first Kepler law, which states that planets move surrounding the sun in elliptical shape. And the sun is in one of the foci of the ellipse. Well, this is also the same. Kepler's second law states that the line segment joining a planet and the sun sweeps out equal areas in equal time interval. So, in the left side, you can see the planets move during the time dt. When the planet's closer to the sun, it moves faster. And during the time dt, the line segment between sun and the planets swept the same size area with the previous one. It means when the planet's close to the sun, it moves faster. That's why the planet's speed is not constant in the sky. In the Kepler third law states that the square of orbital period of the planets proportional to the cube of semi-major axis of its orbit. So period square proportional to cube of r. So it means period proportional to square root of the distance between the planets to the sun. So there is direct relation between period and frequency. So the frequency proportional to square root of 1 over cube of r. And in the mathematical expression, mathematical equation, we can write. So if we know the distance between the planets and the sun, we can convert this distance into frequency by choosing certain value of k. This value of k should equal for all planets. Therefore, we can convert the distance of the planets to the sun into frequency. As Kepler states that the distance between a planet to the sun is not constant because the orbit is ellipse. So there is sometimes the planets closer to the sun, sometimes further. It means the speed and the frequency is also different. Yeah, it's also changed. When the sun, when a planet in the close distance to the sun, we call the planet in perihelion position. If the planet's far from the sun, we call it an aphelion position. So from its distance of the planets to the sun, by choosing conversion value k, we can calculate frequency and we can fit musical tone. And it means for planets which is closer to the sun, it has higher frequency. The planet with distance far from the sun, it has a lower frequency. The limit of frequency range for each planet can be defined by perihelion and aphelion distance. So what kind of tone each planet can give to us? Maybe Bu Devi can show us the tone. Maybe this is my part, and later about the music, Bu Devi can explain better. Thank you.